Hi, this is another video in the tutorial Trees-Based Methods. This is the course Digital Economy and Data Analytics. My name is Eik van Vuren and I would like now to go on with respect to classification. Well, we should realize that so far we have been only talking about regression, but another thing that we should realize is the fact that these trees-based methods, they are essentially very powerful at the moment that we are going to look at classification. Even though, of course, they can also be used for the case of regression, they are essentially powerful or especially powerful in the case that we are going to think about classification. So therefore, what we are going to do next is that we actually want to look at classification as well. Now, an important thing to realize is that even though there are, of course, differences between, say, regression on one hand and classification on the other hand, well, most of the things that I have said so far with respect to trees, backing, random forest and boosting actually also hold for the case that we are going to do classification. That is to say that maybe 90%, maybe even more than that, 95 or 99% of all the things that I have said so far, well, they do not really require that much of a different implementation at the moment that we're going to do implement them in Python. However, an important difference between what we have done so far with respect to regression and what we're going to do now with respect to classification is that we should realize is that we need now new libraries. So all the libraries that we have introduced so far for all these different methods, trees, backing, random forest and boosting, they actually don't work at the moment that we're going to do classification. And the reason behind that is because of the fact that we do already know that the splitting rule is different for classification trees than compared to at the moment that we're going to use regression trees. At the moment that we use regression trees, we do already know that the splitting rule is in fact based on the, say, squared error loss function. But we do also know that at the moment that we're going to look at the splitting rule, at the moment that we are going to do classification, then we're going to do it based in fact on the 0,1 loss function, or maybe better to say we are going to do that with respect to the Gini coefficient. So that is an important difference. Another difference is of course with respect to how we are going to predict in the different subsets. Take into account that at the moment that we're going to do that with respect to regression, then we take the average over the observation that we have, whereas at the moment that we're going to look at classification, then we're going to predict that class that is most frequent in a particular subset that we need to predict. So therefore there are important differences between, say, regression trees and classification trees, and therefore we should take that into account by importing different kind of libraries. It doesn't make any sense to, for example, have a regression tree library imported at the moment that we're going to do classification. And that doesn't only hold for trees, but it also holds for backing, random forest and boosting, because of the fact that these of course are based on trees. In order to explain this, what I'm going to do is that I'm going to use a Kaggle dataset, a dataset that comes actually from a website that is called Kaggle, and there we can look at the health risk of individuals. But before we can actually do that, we do need to make some data manipulation. Well, the first thing that we need to do, of course, is to get the data set itself, and we're going to do that again. It's an Excel sheet, so therefore we are going to include it by using this first of all this method, of course, pd.readExcel, and then in addition to that we are going to have then this f string over here that starts of course with an f, and then we are going to include our directory. That's your directory that you have on your computer, and then in addition to that, this is the file name of the file that we are going to include into Python, and then we're going to store it again in this variable df for data frame. Well, then some of the variables, we don't have to do anything with respect to that, but some of the variables, they actually need some further manipulation. And the reason behind that is because of the fact that they are, in fact, they are just written strings. And you should realize that Python cannot do that much about that or with that at the moment that you're going to use trees. So therefore, there are a couple of different, say, categorical variables that are described by strings that we can see as ordinal variables. So therefore we're going to make them ordinal, giving them simply values. And that we can do here. And again, that is enough for trees because of the fact that trees are simply going to split, and it doesn't really matter that much what kind of values we are going to give them. So here we first of all going to do that with respect to exercising, whether somebody exercises or not. We have here 4 different values: none, low, medium, and high, and we're going to give them the values 1, 2, 3, and 4. Well then, we also would like then to look at the health risk. That is our main outcome that we have, and that only has 2 outcomes, low and high, and we're going to give them values equal to 1 and 2. Essentially, it's then just going to be a Boolean, of course. And then we also are going to look at sugar intake, and sugar intake can take values low, medium, and high. And then we're going to, define to be equal to 1, 2, and this 3 that we have over here. The thing that I haven't introduced yet is this, backslash or slash. I'm exactly not sure what of the two it is, but this backslash that we have over here, that is in order to be able to actually write on different lines as I have done over here. Otherwise, if you don't do that, then you get actually an error from Python. And then there is a final variable which is called profession. Well, that's not really an ordinal variable. It just takes a lot of different professions, and therefore we're going to use their dummy. So simply we're going to introduce here pd.getDummies, and then we're going to use this prefix profession, and we are going to do that with respect to this variable profession that we have over here. Well, we then take everything together in this concat that we have over here. We drop the variable profession, and then we finally print out df.info. If you're going to do that, then we're going to get this nice set of variables. Here we have age, for example. We have weight, height, exercise. That's a thing that we have already introduced. So this none, low, medium, and high. We have the number of hours that somebody has been sleeping or is sleeping in general. Sugar intake, we have already talked about that as well, whether somebody smokes, drinks alcohol, is married, and we have some additional things, including, of course, all these different, say, professions that we have over here. I would like now to illustrate the difference between classification on one hand and regression on the other hand by looking at the program with respect to boosting. Well, the main difference that we actually have with respect to this particular program actually is already here at the start, because of the fact that what we need to do over here is that we have to now no longer import gradient boosting regressor, but instead we're going to import here gradient boosting classifier. Well, then we still have some differences. Here, for example, we introduce a constant for the outcome variable with respect to this particular example that we have over here, which is of course called health risk. And apart from that, this is exactly the same as what we have seen before, with one particular difference, and that is that instead of using the mean squared error with respect to the cross-validation risk as we have it over here, we are going to use the zero mean loss function, and that's this thing that we have then over here. And then in addition to that, we also have to change here in this particular line. We should not use gradient boosting regressor, of course, but here we should use a gradient boosting classifier instead. And then the rest of this function is exactly identical to what we have seen before. Well, then at the moment that we're going to look at main, well, these are of course the lines that we had already discussed before, and then we can go on, and most of it looks exactly identical to what we have seen before. Also here we are going to do the cross-validation process, and then of course finally what we also here are going to do is that we should not write down gradient boosting regressor, but instead we're going to use the gradient boosting classifier. And but the idea is exactly the same as what we have seen before. And then then finally we're going to do the prediction, and then also here we should realize that we are not interested in the mean squared error, of course, but instead we are interested here in the test risk, which is now based in fact on, say, the zero mean loss function, and we can actually calculate that based on this thing that we have over here. Take into account that officially, of course, it is the situation in which y-test and predicted y, they must be unequal to each other. Well, it's a little difficult to actually do that here, and therefore what I simply do is that I take here 1 minus the percentage of the cases that we actually have it exactly equal to each other. Well, if we do that, then we print it out, and finally we also need these lines that we have over here. But if we do then if we are going to run this whole program that we have over here, then in the end we will find out that we have 0.3% of misclassification. So only in 0.3% of the cases we actually will indicate wrongly the health risk of a particular person. Well, whether this is high or low, that is a little bit difficult to say, because of the fact that I haven't really looked at any other kind of method, but in my opinion it sounds rather low.